అది న్యూ క్లాస్ స్టార్ట్ అయింది. Good afternoon, sir. Good afternoon, sir. సార్ స్క్రీన్ విజిబుల్ ఉందా సార్? స్క్రీన్ షేర్ చేశాను. గుడ్ ఆఫ్టర్నూన్. Good afternoon, ma.
Good afternoon, ma'am.
Good afternoon, ma.
Good afternoon, ma'am. Good afternoon, ma'am.
I will start. Until others will join, I will start. I shared the screen. Is it visible?
Yes, ma'am.
Today I'm taking from my mobile as my laptop is not getting on.
Oh,
Just we will recall what we discussed. Already I sent this PDF yesterday in the group. Is it?
yes, ma'am.
We checked. Others.
Yes, ma'am.
Fine. We will see the continuation of yesterday's. Just we will go recall what we discussed yesterday. Based on that, we will do further. What we discussed yesterday, rectangular waveguide. I said we will get two essay questions, either rectangular waveguide. What is another question? Cylindrical waveguide. When we will call the waveguide as a rectangular waveguide, if the cross section of the metal tube is in rectangular shape, we will call it as a rectangular waveguide. The cross section of the, you can keep your textbook before and just or PDF and just cross check what we are discussing. Rectangular waveguide. What we can say rectangular waveguide? The cross section of the metal tube is in rectangular shape. We will call it as rectangular waveguide. And the diagram is shown here. B is here, right? And what is A? A is the width of the rectangular area. Using Maxwell equation. What is the basic Maxwell equation we are using? Del cross H equal to dou D by dou T times of J here. And I am keeping J as 0. If in the homogeneous isotropic medium, if J is 0, what we will get? Del cross H equal to dou D by dou T. In place of D, what I am substituting? Epsilon E electric field. In place of dou by dou T, I am substituting J omega. And rewriting, we will get equation number 2. Del cross H equal to J omega epsilon E. And another equation we have, Maxwell equation. What is another Maxwell equation we have? Del cross E equal to minus dou B by dou T. In this place, dou by dou T, I am substituting J omega. In place of magnetic field B, I am substituting mu H bar. And which equation we are getting? We are getting del cross E equation. What is del cross E? Del cross E equal to minus J omega mu H bar. In place of dou by dou T, I substituted J omega. In place of B, mu H bar is substituted. And the wave equations we have, for two wave equations for what we have? For electric field one equation, for magnetic field one equation. And here the magnetic field equation is del cross H. What is magnetic field equation? Del square H equal to minus omega square mu epsilon H bar. And another equation we have del square E electric field equation minus mu omega square mu epsilon E bar. All these things we discussed yesterday, just recalling, and we will go further. And from equation 5, I am solving derivation part for the electric field along the Z direction. Along the Z direction means what we will write? Del square Ez equal to minus omega square mu epsilon. This electric field I am writing in terms of Z axis Ez and expanding the term delta. If I expand the term delta, what we will get? Dou square Ez by dou x square, dou square Ez by dou y square, dou square Ez by dou z square equal to minus omega square mu epsilon. RHS part is written as it is. In place of dou by dou z, what I am substituting? I am substituting in place of dou by dou z minus gamma is substituted. And then again you substitute in the above equation. What we will get? Dou square Ez by, this is this is coming down as it is. Dou square Ez by dou x square, dou square Ez by dou y square, plus dou, in place of dou by dou z, what I am substituting? I am substituting gamma. Gamma, it is square in terms of square. So I am writing gamma square times of Ez equal to RHS side is as it is. RHS side what we have? Across RHS what we have? Minus omega square mu epsilon Ez is written across the RHS side. Again I took Ez common from the third term. If I make Ez common, minus gamma omega square, it is plus gamma omega square And here minus omega square mu epsilon, which is in RHS side, I am writing to the LHS side. Next, this gamma square omega mu epsilon is treated as what? One constant kc square. And rewriting the equation again, dou square Ez by dou x square, dou square Ez by dou y square, Ez times of this term I am treating as a kc square of Ez equal to 0. Similarly, I wrote equation for whatever the equation 6 we wrote is for electric field. Same way, one more equation is written for magnetic field. What is the equation for magnetic field? We have dou square Hz by dou x square, dou square Hz by dou y square, kc square times of Hz equal to 0. Now we have to solve these equations for what? For x parameters, for y parameters, and for z parameters, for both electric field as well as for the magnetic field. For electric field, what we will call Ex, Ey, Ez. For magnetic field, we will call it Hx, Hy, Hz. Now from equation 2, what we have equation 2 above? What is written equation 2? Equation 2 is del cross H equal to j omega epsilon E. From equation 2, what I am modifying? J omega epsilon E. Now this epsilon term I am splitting. E equal to E naught e power j omega t I am substituting. In place of delta, what I am writing? I am writing I times of dou by dou x, j times of dou by dou y, k times of dou by dou z. And electric field E is written as Ex, Ey, Ez, and magnetic field H is written as Hx, Hy, and Hz. Now we are substituting all these equations. For that, I am first calculating the cross product of the equation. What are the terms we have? I, J, K. I, J, K. Another is dou by dou x, dou by dou y, dou by dou z. And Hx, Hy, H terms I am solving for H terms. Hx, Hy, Hz. And now we are making matrix, this determinant multiplication. Vector multiplication. I times of what? Dou Hz by dou y, dou Hy by dou z. Next is j term, k term we calculated and substituted here dou in place of dou by dou z. What I am substituting? In place of dou by dou z, I am substituting gamma and I solve the equation. And I compared both LHS and RHS side, ith term, jth term, kth term, and I wrote equation numbers as 8, 9, and 10. After writing same way, just now for which one we calculated? We calculated 8th equation, 9th equation, 10th equations for the magnetic field. Same way we are calculating for the electric field and wrote equation numbers is what? 11, 12, 13. All these things yesterday class we discussed. Next, after calculating 11, 12, 13, what we did? From equation, just simplifying equation 12. From equation 12, I am calculating Hy parameter. What is equation 12? Equation 12 is dou Ez by dou x plus gamma times of Ex equal to j omega mu times of Hy. From this, I am calculating Hy. Just to turn the j omega mu is brought to the left hand side. That is 1 by j omega mu by dou Z by dou x plus gamma times of Ex equal to Hy. From there, I calculated Hy. Now, this Hy term I am substituting in equation number 8. What is equation 8 we got previous? What is equation 8? Equation 8 is dou Hz by dou y plus gamma times of Hy equal to j omega epsilon times of Ex. In this I am substituting LHS second term Hy. After substituting in Hy, what we are getting? This star means here Hy. This star I am substituting in where, ma? In equation number 8. After substituting in equation 8, again simplification. And what we are calculating from this after 3 to 4, yesterday we discussed this one simplification part. After simplification part is done, we are getting Ex value. What is the value of Ex? Here Ex value is 1 by kc squared of, after simplification we are getting Ex. Similarly, I wrote Ey, Hz and Hy. These are rectangular wave equation. These four are very, very important rectangular field wave equations. You will get question as a write about field equations of rectangular waveguide. If they ask field equations, you have to write up to which equation? Equation number 14, 15, 16, 17 we have to write. Next, now we will solve the constant term. What is here the constant term? Constant term is Kc square. From the previous, in the beginning part, what is the Kc, ma? What is Kc square we got?
Gamma square plus omega square.
Square omega mu epsilon. From that, gamma is calculated. And what is omega, angular frequency omega? What is angular frequency omega? 2 pi fc. From that, I am writing 2 pi fc. From that, I am writing kc by root mu epsilon. And kc of mu naught. From the previous equation, we will write this one. Where we got previous one here? kc by
root into mu epsilon.
Kc by root of mu epsilon, we will get kc times of frequency nu naught. From this, we are calculating what? Wavelength. Wavelength lambda c we are calculating. How to calculate lambda c formula? What is the formula of lambda c? Nu naught
Mu
by.
naught by fc.
From that, we are writing substitution 2 pi by kc value omega c under root of mu e. So we calculated up to wavelength. Now up to here we discussed yesterday, is it?
Yes, ma'am.
Now we will see today's fresh topic. What happens in TM mode, what happens in TE mode, and how the field strength varies in TE mode and TM mode. Now we will see. Now next continuation of this one is, suppose I am working along y-axis. If I work along y-axis of the boundary conditions from 0 to b, at that time what happens? E tangential equal to 0 for y equal to 0 to b. Suppose I am working for the x-axis. If x-axis is 0 to a, again the E tangential value equal to 0. These boundary conditions we will use in the next derivation part. In our next derivation part, what we will do? Transfer magnetic field wave, transfer electric field waves, derivation part we will see. Now first we will start transfer magnetic field waves. From the previous boundary conditions, if we are using y parameters from 0 to b, at that time what happens? X as well as z both are 0. Suppose you are using x, at that time what are the remaining things? Y and z is 0. Here I am using y term. If y term boundaries conditions I am using, at that time Ex and Ez is 0. Suppose I am using x boundary conditions. X is equal to 0 to x is equal to 0 to x equal to a. At that time which is 0? Ey and
Ez.
Using this one, now we are doing further processing. Now previously we got one equation 3.8 in terms of Ez. That is this equation dou Ez. What is the equation? Dou Ez by dou x square plus dou square Ez by dou x square plus dou square Ez by dou y square plus gamma Ez equal to, what is RHS term? Minus omega square mu epsilon Ez. From this, I am making this one equating to 0 and making Ez common from LHS side. If I make Ez common across LH side, if I make Ez common across LHS term, what are the terms? Dou square by dou x square, dou square by dou y square, plus gamma square times of Ez equal to 0. Is it gamma square or Kc square? Is 18th equation.
Kc square, ma'am, because gamma square plus omega square mu epsilon equals to Kc square.
Very good. Okay, as the Kc square value is gamma square plus omega square mu epsilon. So I am writing directly Kc square. Now what we will do? We will consider two parameters x and y. And we will multiply. Here I am imagining Ez equal to x of x, y of y. And I am multiplying this one to the previous equation. What is the previous equation we have? Dou square by dou x square, dou square by dou y square plus Kc square terms of x of capital X of x, capital Y of y equal to 0. Now what I am doing? Dividing numerator and denominator. Next step is what is? We have to differentiate partial differentiation with respect to x. At that time, which term is constant here? Y term is constant. If I do with respect to x, If I do with respect to y, which term we have to write constant? X term. That is written here. Dou d square x by dx square. In the denominator we have x. So I am writing as d square x by dx square. Which I am keeping as it is. Y term is kept as it is. Here denominator what we have? Y term. So the x term I kept as it is. And d square y by dy square plus kc square of x of x and y of y equal to 0. Differentiation is done in this step. After differentiation, divide numerator and denominator both with x and y. We are dividing with x and y. What we will get after dividing? Divide with xy. Here you write xy. This side also you write xy. So what we will get? Y is cancelled and only x is left. 1 by x times of d square x by dx square. Next here y is xx is cancelled. 1 by y times of d square by dy square plus kc square equal to 0. From this, kc square is d square x by dx square. Now what I am doing? I am writing two terms separately. One side, first I am choosing x term. Next, separately I am choosing y term. First, I will solve for the x term. What is x term here? Dx square of dx square plus kx of this denominator x. This denominator x is multiplied to this one. Dx square of dx square plus kc square of x equal to 0. Next, I took this multiplication. Y is multiplied to this one. Then what is the equation? D square y by dy square plus ky square. In writing in place of c, I am writing in terms of x and y. Ky square of y equal to 0. This is equation number 22 and equation number 21. Two equations wrote separately. For these two equations, I am taking simple harmonic residual equation to simplify this one. What is the simple harmonic equations in terms of x and y? I am writing. What is x? X equal to a1 cos kx plus b1 sin kx. Y equal to c1 cos ky d1 sin ky. Where a, b, c, d I am choosing as a constant. Now next what I will do from this is, we are working along z-axis. If we are working along z-axis, from this, what I am doing here is, I am keeping a1 term and c1 term to 0 in this equation. In this equation, I am keeping a1 equal to 0, c1 equal to 0. Then what happens? These two terms is completely equal to 0. So in the first, which term is left in the x? X only one term is left. What is the term? b1 sin kx of x. In y term, which term is left? d1 sin ky of y. Now what I am doing? I am doing multiplication of x dot y here. X dot by multiplication, two terms is written, and I am saying as C1 equal to 0 as well as A equal to 0. If A and C both are 0, we will get B1 D1 times of multiplication of both. Multiplication of both, what we will get? B1 D1 of sin kx of x, sin ky of y. Here, this one is here. See here, this side. So this is like it is in there. After keeping a as 0, c as 0, b1 sin kx of x, d1 sin ky of y. This b1 d1 I am treating as a one constant. What is that constant? That constant is called as a. Next, after making constant, I am taking only individual variable sin kx of a equal to 0. From there, kx of a equal to, I am treating as a integer of pi, m pi. From there, I am writing ka. What is the value of ka? Ka in x is writing in terms of a. Ka is equal to m pi by a. Is this clear up to here?
Yes, ma'am.
Yeah. This my document gone 1 minute, huh? Where is the final last 1 minute? Where we discussed on this? Ex, Ey, Z, we calculated the term Ka. Next, we will same way, we will calculate the next term is Kb. Up to which part we completed in this? 1 minute. Up to 13th page is completed. Similarly, I am writing another term. What is another one? Ka is over. Next, ky of ky b equal to n pi. From this, I am calculating ky. What is ky? N pi by b. Now, Ez of xyz. Again, we are taking our equation. Ez of xyz equal to a sin kx of sin ky. From where we got this one? A is b1 d1. Just now I shown here. From here. Again, I am writing this equation. A sin kx of x and sin ky of y. In place of kx, which one I am substituting here? M pi x by a. In place of ky, I am substituting n pi x by b, where a and b are constant. So we calculated ka value and kb value and substituted. Again, I am writing here electric field equation Ex, Ey, Hx, Hy in terms of along x-axis, in terms of along y-axis. Array. 14th page. In terms of along x-axis and in terms of along y-axis. So here from now up to where we did, we calculated kx and ky from equation 14. What is equation 14, ma? Again from equation 14, I am writing Ex equal to minus kc square times of j omega. Already we simplified Ex, Ey as well as Hx, Hy. From equation 14, again I wrote equation 14. In this equation 14, I am keeping Hz equal to 0. If I place Hz equal to 0, what happens? First term becomes 0. Only second term is left. Ex equal to minus 1 by kc square gamma times of dou z by dou x. Now what we have to do? Substitute 30 in 29. What is 30? We know that gamma equal to alpha plus j beta. Here I am keeping alpha equal to 0. So we will get gamma equal to j beta. That gamma equal to j beta I substituted in equation number 29. So we got Ex equal to minus j beta times of kc square times of dou z by dou x. Again substitute 28 in 31. What is 28? We know that dou z by dou x. What is dou z by dou x, ma? Dou z by dou x equal to a sin kx sin ky. That is substituted here. After substituting, we got final equation. What is after substituting? Final equation is what? Now differentiation with respect to what is sign of differentiation? Minus cos. Kx is
No, ma'am, plus cos.
Plus cos. Kx is came here and a is coming to the beginning. In place of sin x, cos x is written. And second term is writing as it is sin ky of y. Similarly, we got remaining equations. What are the remaining equations? How we simplified Ex? Same way, Ey is written, Hx is written, Hy is written. All these four are electric field equations. In our textbook, what are those equation numbers? In our textbook, the equation numbers are
3.27, 3.28, 3.29, 3.30, ma'am.
Points is a good. So same type of equations we got for which one? Electric field equations for rectangular waveguide. Now what is these for equations? Electric field equation. Sorry, these are for rectangular waveguide only. Transfer magnetic TM mode. So these four equations represents TM mode equation. Same way in the TE mode also we have to simplify total 4 equations. So rectangular waveguide we have 4 equations to learn. In TM mode we have 4 equations. Similarly in the TE mode also we have 4 equations. After completing this, what we are doing? We are calculating cutoff wavelength of TM mode as well as cutoff frequency of TM mode. And now we will see what is cutoff wavelength of TM mode. In cutoff wavelength of TM mode, we know what is Kc square formula. Kc square is equal to gamma square omega square mu epsilon. Is it? And in this, I am keeping gamma square equal to 0. So we get Kc square equal to omega square mu epsilon. From this, I calculated omega. What I calculated? I calculated omega. Next, and we know that omega equal to Kc nu naught. What is omega? Omega equal to 2 pi Fc equal to Kc V naught. From this, I calculated nu naught by Fc. If this is clearly written in the textbook, you can refer. Nu naught by Fc equal, we can write this as a lambda. Nu naught by Fc naught, we can treat as what? Lambda. Lambda c. Lambda c equal to what we got? 2 pi by Kc. Lambda c we got 2 pi by Kc. Again, I substituted 2 pi by, what is Kc? Kc here is Kc is written in terms of x and y. Kc equal to kx square plus ky square. So here only Kc is asked. So I kept under root. Kc equal to under root of kx square plus ky square. Previously we discussed what is Kc? M pi. What is
Kx
K?
plus ky only, ma'am.
Ah.
And then we put it square and root both.
Square and root. M pi by a whole square, n pi by b whole square.
Now putting kx and ky value.
Putting kx and ky value. Very good. Now pi is cancelled with numerator and denominator. Finally, we got wavelength. What is the wavelength formula? Lambda c equal to 2 by under root of m by a whole square plus n by b whole square. So what we calculated? We calculated cutoff wavelength lambda c. Next, what we have to calculate? Next, we have to calculate cutoff frequency Fc. Now we will see cutoff frequency Fc, how to do. From equation 36, in general, we know frequency Fc equal to nu naught by lambda c. 2 by Fc equal Kc by root mu epsilon. This one we already got. The next, 2 pi is brought to the RHS side. We got Fc equal to Kc by 2 pi under root of mu epsilon. From this, again Kc is substituted. What is Kc? Under root of n by whole square plus n by b whole square by 2 times of root mu epsilon. So up to here, this is TM mode. So if you get exam question, how you will get question mark? Just check the backside questions. Now which one we solved?
TM.
We solved derivation for which one? Backside model questions is there. Just you can refer.
Ma'am, third question, discuss the propagation of TM waves in a rectangular waveguide.
Discuss the propagation of TM waves in rectangular waveguide. Now we discussed fourth equation.
Frequency cutoff wavelength. That
Ikkada
question is not there, ma'am.
The fourth question undi kadamma. Field equations ante rectangular waveguide equations rayali. Now we discussed fourth one. Is it? Up to ekkada varaku rayali cutoff frequency rayali. Now we will go to transfer electric field. After discussing TE mode and TM mode, we will come for the electric fields. Electric fields tarvata chuddam. Next ఈ derivation part kuda chusaka next time cover chedamu. Two electric field parts for TE mode as well as TM mode. Now we will discuss which one? Transfer electric waves.
Ma'am, see once sixth question, ma'am. Derive expressions for lambda c fc that are the cutoff frequency and cutoff wavelength.
Cutoff wavelength for TM mode.
Yes, ma'am. Sixth question, ma'am.
అవును same question. Just now we discussed frequency wavelength. అదే వస్తుంది.
Yes, ma'am.
Now we are starting TE mode. TM mode is completed. Next we will come for TE mode. After discussing these two, again we will come for the field patterns afterwards. Next, see TE mode. There what we did, Ez equal to 0. At x is equal to 0 to a. Did you remember how we started the answer? Across the tangential. See here. How we started. Starting point. For y parameters, ex and ez equal to 0. For x parameters which are 0, ey, ez is equal to 0 and hz equal to 0. Same way now we will write for TE mode. Same type of equations we have to start for TE mode. How to start answer? First we have to start the answer with the boundary conditions. For TE mode, ex equal to 0 and hz is present. For electric means ex is equal to 0 and magnetic field is present. Next, what are the boundary conditions? Hz equal to 0 for x is equal to 0 to a and hz equal to 0 for y equal to 0 to b. Again, first I started with wave equation. This wave equation is already we saw in the previous. What is the magnetic field wave equation? Dou square hz by dou x square, dou square hz by dou y square plus kc times of hz equal to 0. Again, there we did variables xx and yy. Same way here I am taking xx and yy as variable. Answer వస్తే ఈ ఆన్సర్ ఈజీ అమ్మా. టీఎం మోడ్ వస్తే ఇది ఈజీగా అర్థమవుతుంది. Dou square by dou x square plus dou square by dou y square plus kc square. లోపలికి మల్టిప్లై చేసి డినామినేటర్ ని ఎక్స్ వై తోటి డినామినేషన్ చేసి టూ టర్మ్స్ ని సపరేట్ రాస్తున్నాం. వాట్ ఆర్ ద టూ టర్మ్స్ సపరేట్లీ we are writing? Dou square x by dou x square plus k square x of x equal to 0. What is second equation? Dou square y by dy square plus ky square times of y equal to 0. We wrote two equation. For simplification, writing in simple harmonic equation, this one we wrote. Did you remember what we did in TM mode with this equation? ఈ ఈక్వేషన్ కి మనం TM mode లో ఏం చేసాం? Anyone? A1 C1 is 0 పెట్టేసాం. గుర్తుందామా?
Yes, ma'am.
There in TM mode we kept A1 equal to 0, C1 equal to 0 and we wrote B1 dy sin kx sin ky of y. Where? In TM mode. But here what I am doing? Here I am keeping B term
B1
and
is equal to 0.
this term I am keeping 0 and cross multiplying these two terms. If I multiply x and y, what we will get? A1 cos term plus C1 cos term. So final term one we are getting A1 C1. A1 C1 of cos kx of x, cos ky of y. This A1 C1 I am imagine as one constant. What is that constant imagination? That constant is B. Same way what we did previous, here also I am calculating kx and ky. And in place of cos kx plus I will substitute n pi by y. In place of ky, I substitute n pi by b. From previous equation 14, now I am writing further 4 equations we have to write. Is it? For each one we have to write 4 equations. From previous simplification, I am writing ex. How to simplify ex? If we get one remaining, we can write easily. And now how to simplify ex? We will see now. What is ex equation? Minus 1 by kc square times of j omega mu dou hz by dou y plus gamma times of dou ez by dou x. Ez equal to 0. And next, if ez equal to 0 means this term becomes 0. What happens to this term? This term is 0. Next, ex equal to 2. Rewriting the equation, j omega mu is in the numerator, kc square is in the denominator, and dou hz by dou y is copying as it is. And next, see minus j omega mu by kc square, dou by dou y of what is hz we got? Hz we got with some constant. What
B
is hz?
cos kx cos ky y.
B cos kx of x, cos ky of y. Now j omega by kc square times of b ky cos kx of x sin ky of y. Same, if we get one equation, easy to write remaining equation. There also we calculated one equation. From that equation we wrote remaining 3 equations. Same way after calculating ex, we had to write which equations? Ey, hx, hy. ఇవి క్యాలిక్యులేట్ చేసినాక ఏం చేయాలి? మళ్ళీ కట్ ఆఫ్ ఫ్రీక్వెన్సీ క్యాలిక్యులేట్ చేయాలి, cutoff wavelength calculate చేయాలి answer కి. Same way here EY equation. What is the difference between EX and EY ma? EX EY కి ఏంటి difference? How to remember it for the exam?
X, there is X, KY, there is a KX.
Plus and minus difference, and where kx is left side, right hand side ky.
Cost term is in terms of X here. Here cost term is in terms of Y. Here
Y
sin
term.
in terms of Y. Here sin term is in terms of X. That is the difference. Okay. And next same way we have to write remaining two equations. What are the remaining two equations? In terms of magnetic field. Where what is Kx and Ky? Where Kx equal to n pi by A and Ky equal to n pi by B. And Kc square equal to Kx square plus Ky square. Using this, how we calculated wavelength lambda C and Fc. Here also I am calculating lambda C and Fc. Now what is lambda C? Lambda C formula is 2 by under root of m by a whole square plus n by b whole square. Next, cutoff frequency. What is cutoff frequency formula? Fc equal to under root of m by a whole square plus n by b whole square by under root of 2 by mu epsilon. I'm going to just go through once this derivation. If this is okay, I will start electric field patterns. Just go through this one in your book. What we did derivation part. We calculated frequency as well as cutoff frequency and wavelength, group velocity, like different parameters is calculated. So we completed rectangular waveguide.
Ma'am, ఈ టీఎం మోడ్ ఫీల్డ్ ఈక్వేషన్స్ అన్నా కూడా ఇది కట్ ఆఫ్ ఫ్రీక్వెన్సీ కట్ ఆఫ్ వేవ్ లెంత్ వరకు రాయమన్నారు కదా మ్యామ్ ప్రీవియస్ టీఎం మోడ్ లో. మళ్ళీ ఇక్కడ టెక్స్ట్ బుక్ లో ఫీల్డ్ ప్యాటర్న్ ఆఫ్ టీఎం వేవ్ అని సపరేట్ ఇచ్చేసినారు మేడం, అది వేరా?
అది వేరే, ఇంకా చెప్పలేదు, చెప్తాను ఇప్పుడు.
అది వేరా మేడం?
పేజ్ నంబర్
టీఎం మోడ్ ఫీల్డ్ ఈక్వేషన్స్ అంటే ఇదే కట్ ఆఫ్ ఫ్రీక్వెన్సీ కట్ ఆఫ్ వేవ్ లెంత్ వరకు రాయాలి. టీఎం మ్యాగ్నెటిక్ టీఎం మోడ్ నుంచి ఈ y is equal to 0 to b నుంచి కట్ ఆఫ్ వేవ్ లెంత్ వరకు రాయాలి.
ఇక్కడ వరకు రాయాలమ్మ. ఓకేనా? నెక్స్ట్ ఫీల్డ్ ప్యాటర్న్స్. ఓకే, ఫీల్డ్ ప్యాటర్న్
ఇస్ డిఫరెంట్ ఫ్రమ్ దోస్.
పేజ్ నంబర్ 21 లో ఉంది చూడండి.
yes ma'am.
The field patterns of TE mode is different. Field patterns of TE mode is again it is also different.
Okay ma'am. Field equations ante avi rayali.
Derivations simply cheyali.
Okay ma'am. Clear ma'am. Thank you.
Next we will see what field patterns of TM waves. Before discussing field patterns of TM mode, just I will give the small introduction how the field is varying in this. So, in whiteboard, I will explain this one. Screen share అవుతుందమ్మా?
Yes ma'am.
First I am explaining TM mode. 1 minute. First I am explaining TE mode. This is not in the textbook. Just how general it will work, we will see. Rectangular waveguide. In this rectangular waveguide, width and B, what is B? B is height. In this, now field along X with respect to X, like this one. Field is along with respect to A, here X not XA. Field, the variation along across A is like this. The variation across B is like this. So how the points are looking? 1, 2, 3. Next 1, 2, 3. Horizontal lines is with respect to A. Vertical lines is with respect to what? B. Vertical lines is with respect to B. Now, here A term I am treating as M and B term lines I am treating as N. Eraser, just my eraser I am checking. This, I don't know where is eraser. Oh, it's gone. Next line. Next just now. Pencil. Now TMN. All in one direction, it is 1. M equal to 1 because all in one side axis, one direction. Again, vertical also in one direction. So I am writing as T of 1, 1. T of Mn of 1, 1. In the textbook, you have somewhere you will observe while discussing Tm of 1, 1. So what I am calling here as transfer magnetic field of 1, 1. How I am calling this as 1, 1? Page 2. Okay.
They are in only one direction.
One direction, yes. They are only in one direction. These are called as field patterns. What we are discussing, field pattern. Next, another field pattern we will discuss in TE mode only. Two are in upward direction. Remaining two is in downward direction. And next, another two is in upward direction. These are belongs to what? A. With respect to A. Now I am writing with respect to B. My with respect to B is horizontal, only 2. Now what is the value of M? What is the value of N? M is belongs to A. N is belongs to B. N is belongs to what? B. Now how many different directions you will observe? This is 1. Again coming down, changing the spin. 2. Again it changed its orientation.
Zero
3
maybe.
orientations. First, it is in upward direction. Next, it is in downward direction. Next, it is in upward direction. So, what is the value of M? M equal to 3 or M equal to 3.
3.
For B, we have only one orientation, is it? B is only one orientation, N equal to 1. So, the next field pattern is TM. I will send this photo in the group. TM of what we have to write? 3, 1 for this diagram. Tm of 3, 1. And next diagram we will see. Add page. Mobile. Next. Next is. Next third diagram. Here. There is no orientation along X or no orientation with respect to A. And there is a orientation with respect to only B. Vertical is A, horizontal is B. No A orientation, only this orientation. What is the value of B now? 1 orientation, 1. Other orientation is 2. So for A, there is no vertical line. So I am calling this as T of M times of what I have to write? 0, 2. What is the value for this one? Tm times of 0, 2. So how many we discussed? First one we discussed TM11. All this is called as field pattern. This is not in the textbook. I will share this one PDF. So total we discussed 3. Again, I am writing 3 together. 3 I will write together at a time. 3 field patterns of TE mode. What is the first one? Along Y, same orientation. And next along X, same orientation. What is the field pattern value here? TM11. First one is TM11. Next, second one, 2 vertical orientations with up arrow. Next, 2 down orientations. Again, 2 up orientation. We will call TM3. What we will call? TM3. Next, along B orientation is same direction. So I will call this as TM31. Next, third one. There is no A orientation, only B orientation. Only B orientation. 2 at one direction, remaining 2 is in another direction. What is the value of N? Now the value of N equal to 2. The value of M equal to how much? M equal to 0. Then what you will get total final value? Tm times of 0, 2. Tm times of 0, 2. These are the field patterns of Tm. What are these? Field patterns of Tm. Now we will see the field patterns of T mode. TM 0. Now we will see TE mode. First one. Take this. This is A orientation. This is B orientation. This is called as current wave center point is represented with a dot. And across this dot, I am taking dotted lines. Across this, I am taking this is vertical line is M. Horizontal line is N. Here I am writing as a just a small correction. Previous, whatever the 3 I explained was 3 belongs to TE mode. Previous, what we discussed previously, those are TE mode. Now, whatever I am taking, those are TM mode. Previously, what I said was 3. Previous 3 I said, those are for electric field. TE11 I said. Another one, what I said? TE31 I said. Another one I said. TE02. Whatever 3 I said, those are belongs to electric field. Small correction. Now we will see for the magnetic field. For the magnetic field, now whatever I am drawing, these lines is belongs to magnetic field. I will write 3 at a time. First one, this is A. What is the first one? Across width, it is A. Across the height, this is B. A, B, and current wave is across the center. Across this, we have dotted lines. The line A and line B. Here, only one is there. So, I am calling this as TM11. What is this one? TM11. Next, second one, I am doing field pattern of another type. Here, I am taking 4 current waves, 4 dots. How many dots? 4 dots. Across these 4 dots, for this, and M equal to 2, N equal to 2. Here I am writing as TM of 2, 2. TM of 2, 2. Next one. Next, third one. Here I am taking another I am taking 6 dots, 6 current waves. Through this 6 current waves, 1, 2, 3 means these 3 lines is belongs to N, and 2 vertical lines is belongs to M. Then what is the mode? Tm of 2, 3. Tm of 2, 3. Next, I will write all together whatever we discussed. We discussed with single dot as Tm11. Next, 4 dots 2 by 2 matrix type I discussed Tm22. Another 6 dots with 3 horizontal lines, 2 vertical lines. And I said Tm23. So this is the field patterns of which one? Magnetic or electric field? These 3 are which one? Tm and
magnetic field.
so these 3 equations are belongs to magnetic field patterns. Now what we discussed? Electric field patterns. Electric field patterns. What we discussed? TE11. Next TE31. Next TE02. These we discussed. These you have to explain, but this is not given in the textbook. The same thing with some other method is given. Now we will see the textbook format, how it is explained. Is this okay, ma? Whatever I wrote, shared in the whiteboard? Now we will see from the textbook. Unit 1, 2, 3. Passive devices and waveguides. Now, which one we are discussing, ma? Field patterns of TE mode and TM mode. TE and TM from the textbook part, what is written in the textbook part? This page. What is the heading?
Field pattern of TM waves.
Field patterns of TM waves. In this field patterns of TM waves, he is writing magnetic field along x-axis and y-axis. 2 formulas. H of x is directly proportional to what is the equation? H of x is directly proportional to sine m pi by a of x cos n pi by b of y. First equation. With respect to y, what is given? Cos m pi by a of x sine n pi by b times of y. And along z-axis, it is equal to 0. Now the field patterns. See here, this is end view and this is side view. This is end view and this is side view. From this same electric field components is also written. Electric field components for equations is Ex, Ey, Ez. As we are discussing TM modes, in TM modes we have Hx, Hy and Hz equals 0. Whereas coming to the electric field, we have 3 equations because we are discussing magnetic field. Magnetic field low, electric field component is present. So total we have 3 equations for electric field. What are the 3 equations we have? Ex, Ey, Ez. Ex equal to cos m pi by a of x sine n pi b of y. Next, Ey equal to sine m pi by a of x cos n pi by b of y. Next Ez equal to sine m pi by a of x, sine n pi by b of y. So remember one thing, if we are discussing Tm, in Tm, Ex is there, Ey is there, Ez is there. Where is coming to the x-axis magnetic field, we have only Hx and Hy, where Hz component is equal to 0. And you have to draw this diagram. Is this clear, ma? Field patterns of Tm mode from the textbook part.
Yes, ma'am.
Next, we will come to field patterns of which one?
TE waves.
Field patterns of T waves. Up to here only, I think we have in this one. This slide, it is not there, I think. Up to, I have slide up to cutoff frequency wavelength only is there in this slide. Okay, no problem.
No,
Just observe. Just
one
observe.
second.
What is the field patterns of TE waves? You have all of your textbook now.
Yes, ma'am.
What is 3.49 equation? Ex equal to Hy equal to Ez equal to 0. First equation is it? What is second equation? Ey is directly proportional to sine of pi by a times of x. Next, Hx is directly proportional to sine of pi by a times of x. Next, Hz is directly proportional to cos of pi by a times of x. And you have two diagrams, top view as well as end view. From these, what is calculating end view and top view magnetic field patterns of TE10? Just I said what is 10? 10 అంటే ఏంటమ్మా? There is no n, only a untadi. B unda indulo horizontal lines unnaya, only vertical lines unnaya? Figure 3.14 lo.
Only vertical lines, ma'am.
That we are calling TE10. అర్థమైందా? TE10 ఎప్పుడు రాయాలి, 11 ఎప్పుడు రాయాలి?
Ma'am, first we have to write vertical lines. After that, there is no horizontal line. That's why TE0.
0, 1 అవుతుంది.
1 vertical lines are there. So TE1, there is no horizontal, 0. We put 0. TE10.
10.
Okay, ma'am,
Good.
am I correct, ma'am?
Yes. నెక్స్ట్ లో ఏముంది, వేవ్ ఇంపిడెన్స్ డెరివేషన్ చేశారు చూడండి అమ్మా. దీనికి మనం ఫీల్డ్ ప్యాటర్న్స్ కి ఇక్కడ వరకు రాస్తే చాలు. ఇక్కడ వేవ్ ఇంపిడెన్స్ ZZ is calculated. Is it? What is calculated in the page number 27? You have ZZ. What is ZZ?
Wave impedance.
Wave impedance is calculated. Just I am writing final expression. What is final expression of wave impedance?
G is equal to eta by under root of 1 minus FC by F whole square.
FC by F whole square.
Yes,
under
root, ma'am.
Just to refer this for wave impedance of ZZ. So we completed rectangular waveguide part. What we completed? Rectangular waveguide. Next, what we have to discuss?
Circular waveguide.
I think I came to last look వచ్చేసాను అనుకుంటాను. ఇదంతా rectangular waveguide. Okay. Next is circular waveguide. It is not there. Next, I will refer from test this part. So next is what, ma? Circular waveguide. Rectangular waveguide you understood perfectly. Out of 8 blocks, this is lengthy block.
Yes, ma'am. Very lengthy questions are there, ma'am. How can in the examination point of how to we remember? Confusion is there, ma'am, in the examination point.
ప్రాక్టీస్ చేయాలి మా కొంచెం ఇది ప్రాక్టీస్ చేస్తేనే వస్తుంది. నెక్స్ట్ కమ్ టు సర్క్యులర్ వేవ్ గైడ్ and lengthy topics also this one. First, what is circular waveguide? If the cross section of the waveguide in circular shape, then it is called as circular waveguide. There we discussed in rectangular waveguide 3 x, y, z. Is it? Here we will call in terms of r, theta, phi. Here we will write in terms of what? R, comma, theta, comma, phi. Here, just see the diagram. Here we have cylindrical shape and learning along z direction, and r is the radius. What is this wave of propagation is towards up direction we have. This is wave of propagation is along z direction. R is the radius. Here radius of the cylindrical tube I am taking as a. This is along x-axis. This is along y-axis, and this one is along z-axis. Now, using this, we will see the lengthy derivation part. And what is the Maxwell's curls equations in cylindrical waveform? You have to remember these equations directly. What? Just open your book and cross check what are the cylindrical coordinated equations you have. What is first equation? What is first equation, ma? 1 by r. These are Maxwell equations for cylindrical coordinates. Previously, we discussed del cross E and del cross H from rectangular waveguide. Is it? Del cross E and del cross H. Basic two equations. From there, we did complete derivations. Here, we have Maxwell equations for cylindrical coordinates. I think you will get this one in EM theory or in the first year.
Yes, ma'am.
Yes, ma'am.
What are the Maxwell equations for cylindrical coordinates? What is the first equation? 1 by r, dou by dou phi of Ez.
Ez plus gamma E of phi equals to minus j omega mu h.
Mu h. Second equation is minus dou by dou r of Ez minus gamma times of Er equal to minus j omega mu times of h pi. Next equation is dou by dou r. Third equation. What is third equation? Total you have 6 equations. Third equation is dou by dou r of E phi. 3 electric field equations. 3 equations are related to magnetic field. Next electric field equation is what? Dou by dou r of E phi minus 1 by r times of dou by dou phi of Er equal to minus j omega mu times of hz. See, for the first equation, in LHS side what you have, in RHS side what you have? LH side is Z component and phi component. In RHS side what you have? R component. Observe chestunarama? Z component, phi component. RHS side we have R component. And see the second equation? Z, R is LHS, phi is in RHS. And third one? Phi and R is in LHS, HZ is in RHS. Now these three is electric field equations. Now remaining magnetic field 3 equations. What is the remaining 3 magnetic field equation? What is the first equation? 1 by r, dou by dou phi of Z plus gamma phi.
H phi equals to plus j omega epsilon ER.
ER. This is the first equation in the magnetic field. Here which components is there? LHS, HZ, H phi. RHS, R component of R. In the second case, minus dou by dou R of HZ minus gamma times of HR equal to j omega epsilon times of E phi. Here Z component, R component is in the LHS, phi component in the RHS. Next third equation, dou by dou r of h phi minus 1 by r dou by dou phi of hz is equal to j omega z of ez. This is r, I think. hr, this is not z. R or z, amma?
Yes, ma'am. Yes, ma'am. R.
Correct it. R. Dou by dou r of h phi minus 1 by r times of dou by dou phi of hr equal to j omega epsilon times of ez. So you have to learn these 6 equations. Total how many equations, ma?
6.
6.
3 is magnetic field, 3 is electric field, ma'am.
3 electric field equations, 3 magnetic field equations. ఈ 6 ఈక్వేషన్స్ రాస్తే ఇక్కడ నుంచి డెరివేషన్స్ స్టార్ట్ అవుతుంది.
ఇది ఇంకా చాలా లెంత్
సేమ్ ఫస్ట్ ఇందులో కూడా ఫస్ట్ ఫీల్డ్ ఈక్వేషన్స్ రాయాలి. నెక్స్ట్ టీఎం మోడ్ సపరేట్ హెడ్డింగ్ పెట్టి మళ్ళీ ఫీల్డ్ ఈక్వేషన్స్ రాయాలి. నెక్స్ట్ టీఈ మోడ్ సపరేట్ హెడ్డింగ్ పెట్టి ఫీల్డ్ ఈక్వేషన్స్ రాయాలి. మళ్ళీ తర్వాత ఫీల్డ్ ప్యాటర్న్ ఆఫ్ టీఈ మోడ్ చేయాలి, ఫీల్డ్ ప్యాటర్న్ ఆఫ్ టీఎం మోడ్ చేస్తే ఆన్సర్ అవుతుంది. నెక్స్ట్ ఇక్కడ డైరెక్ట్ ఫీల్డ్ ఈక్వేషన్స్ ఇస్ రిటర్న్ 4 ఫీల్డ్ ఈక్వేషన్స్. Directly equations is written. What is the equations we have got from the above equations? Er, E phi, Hr, H phi is written. What is Er? Er equal to minus 1 by kc square j omega mu times of 1 by r dou hz by dou phi plus gamma times of dou ez by dou r. First equation. What is the second equation? లాస్ట్ క్లాస్ లో క్వశ్చన్ పేపర్ డిస్కస్ చేద్దామమ్మా. దాన్ని బట్టి మీకు ఎక్కువ ఏ చాప్టర్స్ చదవాలనేది ఐడియా వస్తుంది. ఓకేనా? కొంచెం మీకు అప్పుడు ఏవి వదిలేసి ఏవి ప్రిపేర్ కావాలనేది కొంచెం మీకు ఐడియా వస్తుంది. నెక్స్ట్
లెంత్ క్వశ్చన్స్ చూస్తే భయం వేస్తుంది ఎగ్జామ్
ఈఆర్, ఈ పై, హెచ్ఆర్, హెచ్ పై 4 ఈక్వేషన్స్ రాసేసాం. దీస్ ఆర్ కాల్డ్ ఫీల్డ్ ఈక్వేషన్స్ వేర్ కేసీ స్క్వేర్ ఈక్వల్ టు gamma square plus omega square mu epsilon. Now I am writing electric cylindrical coordinate lo Ez equation and Hz equation. In cylindrical coordinate Ez equation, what is Ez equation? Dou square r by equation number 3.85 in the textbook lo chudandi. Dou square by dou r square times of Ez, first term. What is second term? 1 by r square dou Ez by dou phi square. Next third term is 1 by r dou Ez by dou r of Ez. Third term plus k is square of kc square of Ez ఒకటి ఉంది, hz. 2 equations ఉన్నాయి for electric field as well as for magnetic field. This equation is electric field equation or magnetic field equation, ma?
Electric field, ma'am. Ez is there.
అయితే ఇక్కడ ఈజెడ్ రావాలి, మిస్టేక్ ఉంది ఇందులో. ఈజెడ్ గీత
రెండు ఉన్నాయి కదా.
దిస్ ఈస్ ఈజెడ్, కేసీ స్క్వేర్ ఆఫ్ ఈజెడ్.
In the textbook it is given in the equation 3.58, ma'am.
This is EZ, not HZ. Correction.
Okay, ma'am.
Next, using method of variable and separate method. There we took x of capital X. Did you remember x of x, y of y? There we took in rectangular waveguide. Just to turn the page number. X of x, y of y, and divided numerator and denominator by x by equation 3.17 in page number 17. Just refer page number 17. Page number 17. Ez equal to x of x, capital Y of small y. From there we wrote, same way here I took Ez equal to what? P of R, Q of Q. And I am rewriting the equation. Again, from where I am taking, this equation is coming down. Just cross check. What is that equation? Dou square by dou r square, making Ez common in the above
Ma'am,
equation.
I forgot their one equation, but my equation, their equation number in above, which you are circling, na, which is right, but I forgot one
Okay,
equation
okay.
there.
Okay, you forgot one equation, but this equation is in terms of Ez.
No, ma'am. In textbook also they given in terms of HZ.
And the magnetic field equation also they given, ma'am. There only
Yes, ma'am.
similarly.
I understood. Two equations is given in the textbook. Just
But
Yes.
observe.
you explain separately, I think, ma'am.
In two equations given in the textbook, no problem. Ez equation is complete equation is in terms of Ez only. Just cross check. First term is Ez.
Yes, ma'am.
Second term is Ez. Third term is
Yes.
Ez. Fourth term is kc square of Ez. You have to
Yes.
write.
Yes, ma'am.
This one only. Only equation completely right. Only one term is missed
Yeah.
wrong. This by
Yes, ma'am.
mistake. Okay.
You have to write easy.
Next,
Ma'am, one thing, ma'am. In the textbook, 3.54, the 555657, the ER, E pi, HR, H pi. How we can write, ma'am? In the
అమ్మాయి ఇక్కడ డైరెక్ట్ వేసేసాము మనం రెక్టాంగిల్ ఫీల్డ్ లో డో బై డెల్ స్క్వేర్ అంటే డో బై డో ఎక్స్ డో బై డో వై డో బై డో జెడ్ ఐజేకే చేసాం చూడండి రెక్టాంగిల్ ఫీల్డ్ లో వెక్టార్
క్లియర్
క్రాస్
గా అక్కడ డెరివేషన్స్ చేస్తాం మ్యామ్ ఎక్స్ వై టర్మ్స్
సేమ్
డైరెక్ట్లీ రాసుకున్నాం.
డైరెక్ట్ ఇచ్చేసాం.
ఓకే ఓకే మ్యామ్. అక్కడ ఈఎక్స్ ఈవై అట్లా కనుక్కున్నాం కదా మ్యామ్. ఎక్స్ ఈవై హెచ్ఎక్స్ హెచ్వై హియర్ ఈఆర్ ఈ పై హెచ్ఆర్ హెచ్ పై డైరెక్ట్లీ దే రైట్.
Lakshmi, we can write x equals to r and y equals to 5.
Yes, yes. Okay.
So we can find the 3.54, 3.55 and up to 3.57.
Yes,
Just,
yes. I got now.
just you have to remember this. Next, now what I am doing, Ez is made common, dou square by dou r square, one from the above equation. This one, dou square by dou r square, 1 by r square, dou square by dou pi square. Third term, dou by dou r of 1 bar. Everything is wrote, Ez is made common. Which is common here? Ez is made common. We are writing equation for Ez or Hz. First we will cross check that one. So both equations are written. For which one we have simplifying? First we have to cross check that
EZ.
one.
EZ.
If it is written for Ez, here you have to mention Ez. Ez of r comma phi equal to pi r q of phi.
In next term we are putting a HZ, but in first term we are putting EZ.
I will cross check this one once again, ma. If any mistake, I will inform you. Whether it is EZ or HZ, again I will cross check once again.
Okay, ma'am.
In the textbook, they also given EZ term, ma'am. After completion of the simplification, EZ answer we got now. After that, similarly, HZ also they write, ma'am, in the textbook.
Yes, yes. Next, what we are doing, HZ of r comma phi. What is we are treating? HZ of r comma phi is what?
P of r.
Q of phi. Here we took x comma y, capital X of small x, capital Y of small y. Same way we took that one. And here what I am doing, to this differentiation, if with respect to P I am working, I am keeping Q in the beginning. Q times of multiplying both.
Same like a yes, sir.
Here for this R you have P or Q undama. For this R, what you have in terms of P? Is it P of R?
In the
So what
textbook, HZ derivation they not given, ma'am. Only Z derivation they
EZ
given.
ఇచ్చారు మేడం.
So ఇక్కడ ఏం చేస్తున్నాము? Q term keeping as it is in the beginning. Q term I am keeping as it is in the beginning. Q term as it is rasi. With respect to R ఉంది. P is with respect to R. So dou square by P by dou R square. ఇక్కడ నుంచి వస్తుంది ఆ ఈక్వేషన్. అర్థమైందా?
Yes, ma'am. Same like previous
Next.
rectangular wave.
In this we have with respect to fire or second term.
5 only.
So with respect to 5 बोल तो क्या करना? P को beginning में रख देना. We have to write this term as dou square phi by dou phi square. Dou square Q by dou phi square. Next third term with respect to R means we have to take P inside, keep Q outside. Is this step clear?
Yes, ma'am. If it is constant, then we are putting in.
Clear. Delete.
Q is constant, we'll differentiate with P, and next P is constant, Q is differentiate. Next again Q is constant, P is differentiate.
Because we are differentiate with respect to R.
Yes. R.
P of R is there, Q of Q is there. If you are differentiating with respect to R, you keep Q in the beginning.
Yes,
if you are differentiating with respect to Q, you keep P in the beginning. Like that, we got this step. Is this step okay?
Yes, ma'am.
Next, multiply by R square, divide by PQ. Multiply whole equation with R square. So what you will get? R square in the numerator and divide by PQ. If I divide with PQ, QQ is cancelled, is it? What
Yes,
we will
ma'am.
get? 1 by P. In that way, we will get this equation. What is the equation? R square by P. This is given in the textbook. Directly is given.
Yes, ma'am, directly given.
Next, what is given? Make R square common. If R square is common, what are the terms is left? 1 by P, dou square P by dou R square, plus 1 by, here we don't have R term. This term is writing here. This 1 by Q, d square by dq square is brought here.
Yes, ma'am.
Able to clear. See here.
మ్యామ్ అక్కడ డివైడ్ బై పీక్యూ అంటే మళ్ళీ క్యూ వస్తుంది కదా మేడం.
డివైడ్ బై పీక్యూ అంటే పైన మీకు ఆల్రెడీ న్యూమరేటర్ లో క్యూ ఉంది చూడండి. ఆ క్యూ ఇది క్యాన్సిల్ ఓన్లీ పి ఒకటే మిగిలింది.
ఓకే
అట్లా మనకి ఈ ఈక్వేషన్ వచ్చింది. ఈ ఈక్వేషన్ లో ఏం చేస్తున్నాను? ఆర్ స్క్వేర్ ని కామన్ తీసాను. ఏ టర్మ్స్ కి ఆర్ స్క్వేర్ ని కామన్ తీసాను? ఫస్ట్ టర్మ్ కి, థర్డ్ టర్మ్ కి, ఫోర్త్ టర్మ్ కి ఆర్ స్క్వేర్ ని కామన్ తీసి, ఈ సెకండ్ టర్మ్ ఉందా, ఈ సెకండ్ టర్మ్ ని ఆర్హెచ్ఎస్ లోకి తీసుకొచ్చా. సెకండ్ టర్మ్ ని RHS లోకి తీసుకొచ్చి రిమైనింగ్ టర్మ్స్ కి R² కామన్ చేశాను. నెక్స్ట్ దిస్ R² RHS టర్మ్ ఐఎమ్ ట్రీటింగ్ యాజ్ N².
మ్యామ్ మీరు R² కామన్ తీస్తే థర్డ్ టర్మ్ లో R/PQ ఉంది కదా మ్యామ్.
అందుకనే డినామినేటర్ లో వచ్చింది చూడండి R/R² చేస్తే ఏమొస్తుంది, డినామినేటర్ లో ఒక R మిగులుతుంది. చూడండి ఇక్కడ డినామినేటర్ లో మిగిలింది. లెఫ్ట్ R ఇస్ ఇన్ ద డినామినేటర్.
ఆల్రెడీ DR
ఫస్ట్ టర్మ్ లో R² తీసేస్తే ఏమేమి మిగిలినాయి, 1/P ∂² P/∂R². Is this clear? First term.
yes.
Next check in the third term. Divide with R² means what you will get? R/R² ఏమొస్తుందమ్మా,
1/R.
1/R. 1/R already you have P. 1/PR ∂P/∂R. Third term. Next fourth term లో ఏముంది, ఓన్లీ KC². Next second term is came to
ఎలా వస్తుంది తీయలేం కదా.
KC²
కామన్ కదా మ్యామ్ అక్కడ.
కామన్ కదా, R² కామన్.
R² common na.
బట్ ఇన్ ద ఈక్వేషన్ వి డజంట్ ఓన్లీ KC² R² ఉంది, అక్కడ లేదు కదా.
లేదు, ప్రీవియస్ ఈక్వేషన్ కి మల్టిప్లైడ్ విత్ R² చేసాం చూడండి. మనకు R² ఎక్కడి నుంచి వచ్చింది. See the step previously, what is there? Multiply by R² and divided by PQ, previous equation.
కానీ KC² R² రావాలి కదా మ్యామ్ అక్కడ అన్నప్పుడు.
ఉన్నది చూడండి, R² ఉన్నది ఇక్కడ ఉంది చూడండి.
ఉంది కాబట్టి అక్కడ కామన్ R² తీసేసుకున్నాం.
లేదు, మీరు స్క్రిబ్లింగ్ చేశారు కదా, దాని నుంచి డౌట్ వచ్చింది.
ఓకే
Got it.
Is this clear up to here? Next,
Yes, ma'am.
treating RHS term as N² and writing as one equation. What is that equation? ∂² Q/∂phi² plus N² Q equal to 0.
మెల్లగా కొంచెం పోయి.
Shall we continue in the next class?
ఓకే
Yes,
మ్యామ్.
ma'am.
మీరు ఒకసారి రివైజ్ అయితే చేయండి అమ్మా, వాట్ వి డిస్కస్డ్, because this is lengthy topic. Even we discuss, it will take 1 more hour to complete cylindrical waveguide.
Yes, ma'am.
So we will continue in the next class. We will recall and we will complete in the next class. I will stop here.
మీరు PDF పంపిస్తారా ఇది?
Already I sent, just cross check in the group.
ఓకే థ్యాంక్ యూ.